We're now going to talk a little bit about functions. It turns out that we have a nice way of indicating functions. We say y equals f of x, which means y is a function of x. And to give you a sense of it, this x is like a placeholder. It holds whatever values we're going to put in. So as an example, if I said y equals x squared, another way I can write that is to say f of x equals x squared. And we know from this that we have a table of values. We have x, which are our values that we input, and y is what we get out as a numeric value. If I say x is 0, out comes 0 squared, which is 0. I can write that by saying f of 0 equals 0 squared, which is 0. What goes in here is the x value. What comes out, the answer, is the y value. If I say f of 4, I know f of 4 is 4 squared is 16. When you see f of 4 is 16, you automatically see that when x was 4, y was 16. And in terms of graph, this means the ordered pair 4, 16. So what we have is a shorthand notation. This becomes a notation for saying the same thing as an ordered pair. For this particular problem, f of x is x squared, that notation is going to have a life of its own. So if I know f of x is x squared, I can say find f of a. Well, that just means everywhere I have x, I have to put in a. And so this becomes a squared. So what I like to do with this kind of problem is I like to think of it this way. F of something is parentheses squared. This is saying the same thing as f of x is x squared. Whatever I'm going to put in the parentheses here is going to go in here. This is the squaring function. So as crazy as it seems, if I say, what is f of box? According to this, whatever box is, the answer is going to be box squared. So given this function, I said, what's f of a? Well, I might say first, I might say find f of negative 2. Well, that just means it's like I said, there's a negative 2 in here, so it'll be negative 2 squared, which is negative 2 times negative 2 is positive 4. But then I might say, what is f of a plus 3? Well, if you look at what this is, everywhere you have x, you're going to be squaring it. So that's why, in a way, I can put in a plus 3 here, and I get a plus 3 squared. So what is that? It's just a notational, and you come up with what that is. So this requires remembering back to simplifying it further. It was a plus 3. A plus 3. And of course, we're going to do more with this. But you guys might remember how you foiled this. Yeah. Remember you went a times a squared, 3a and 3a, 6a, 3 times 3 plus 9. But that's basically what we're doing. Does this have meaning in terms of actual numbers on the graph? No, but it will mean different things in higher mathematics. So it's using this notation to go on, and so the notation takes a life of its own. Now, in all these problems, f of whatever, negative 2, it's going to be based on whatever function you will be given. So I have to give you that. It's not always going to be x squared. It'll be whatever I make up. So, and one more, if I had said, what is f of 2 over h? Well, again, you're going to put 2 over h, and you're going to square it. 2 over h squared. And that would be 2 over h times 2 over h. And we know how to multiply our fractions. 2 times 2 is 4. H times h is h squared. So what we have is we have that this notation has a life of its own. Now sometimes we want to talk about two functions at the same time. So we might call one function, y is f of x, a function of x, and we might have a second one, g of x. We don't use in the same problem the same letter, because you can't say two functions. So as an example, we might say one function, f of x, is x plus 2, and g of x is 3 minus 2x. So we've got two different functions. And one of the things we can do with these functions is we can add them together, subtract them, multiply them, and divide them. So one of the things we're going to do with these functions, we're going to add the functions. I'm going to abbreviate functions. So f plus g of x means we're going to add f of x plus g of x. I'll go to the next page. We're going to subtract functions. So we'll do f minus g of x, which means we did the subtraction of the two, which is you have one function minus the other. And we will also multiply and divide. But let's look at adding the functions first. To do f plus g, adding the two functions, we're really doing f of x plus g of x. Literally, what you do is you just put in f of x is x plus 2, and then you're going to put in what g of x is. G of x is just 3 minus 2x. And the sum of those two functions will just be adding those expressions. So that will just be x and negative 2x, negative x, 2 and 3 plus 5. So the sum of those two functions is this new function, negative x plus 5. What we're really doing is adding two lines, and we get a third one. So now we'll look at what would f minus g of x be. It's going to be f of x minus g of x. So we put that f of x is x plus 2 minus g of x is 3 minus 2x. So this is x plus 2. Now we distribute that through negative 3. Negative times negative 2x plus 2x. And sure enough, x and 2x is 3x. 2 and negative 3 is negative 1. So that's what the function would look like when you subtract it.